Did you know that the sun beams enough energy onto the Earth in just 1 hour to power the entire human race for an entire year? But how exactly do we turn that sunlight into the electricity that powers your fridge, your TV, and your lights? In this video, we're peeling back the glass and silicon to reveal exactly how solar panels work at an atomic level. Let's get into it. Have you ever looked at a solar panel and wondered how a plain-looking, shiny blue rectangle turns daylight into free electricity? It seems like futuristic sorcery, right? But the reality is much more fascinating. In fact, it all boils down to an incredible, invisible dance between tiny particles of light and the basic elements of the Earth. Let's start at the very beginning, the sun. The sun is essentially a massive nuclear reactor. Every single second, it emits billions of tiny packets of energy called photons. These photons travel 93 million miles through space, arriving at our planet in just over 8 minutes. The solar panel's job is to catch these photons. But a solar panel isn't just a sheet of glass. It's actually a sandwich of layers made of crystalline silicon, built with highly advanced semiconductor technology. A standard silicon solar cell has 2 different layers. The bottom layer is the N-type layer, which has been treated to have extra electrons. The top layer is the P-type layer, which is spaces waiting for electrons. These are called holes. Because these 2 layers sit together, an electric field is created right in the middle, acting like a one-way street. Here is where the magic happens. It's called the photovoltaic effect. When a photon strikes the silicon cell, it hits an atom with so much force that it knocks an electron entirely out of its orbit. The freed electron leaves behind a hole. Because of that built-in electric field we talked about earlier, these freed electrons aren't allowed to just float around. They are forced to travel in one specific direction. They move into conductive metal plates, shoot out of the panel through a wire, and flow freely. That continuous flow of electrons is electricity. So, we've successfully captured the sun's energy and turned it into electricity. But there's a massive catch. The electricity the solar panel generates is direct current, or DC. But your home and all your wall outlets run on alternating current, or AC. If you try to plug your TV directly into a solar panel, it wouldn't work. We need a translator. This translator is called a solar inverter. The DC electricity generated by your solar panels flows directly into the inverter, which rapidly flips the current back and forth to create AC electricity. Once the power has been converted, it flows from TH inverter into your home's main electrical panel. From there, it feeds your lights, charges your phone, and runs your everyday appliances. You are effectively powering your home with free renewable energy generated directly by the sun. But what happens if your solar panels produce more energy than you are using? Say in the middle of a sunny afternoon when nobody is home. That extra energy doesn't just disappear, it gets sent back out to the local grid. In many places, this is known as net metering. The utility company tracks how much excess energy you send to the grid and gives you a credit on your electricity bill. Basically, your meter runs backward, and the power company pays you for your extra sunshine. Now you might wonder, are solar panels actually efficient? Historically, panels converts only about 10 to 15% of sunlight to electricity. Today, modern next-gen solar technologies like Topkin and bifacial cells regularly cross 23 to 24% efficiency. This means that even on smaller rooftops, you can generate way more power than you could a few years ago. And the best part, there are 0 moving parts. The only thing moving inside the solar cell is the electrons, because nothing is wearing out or being consumed. Solar panels can last for 25 to 30 years, continuing to produce clean, reliable energy well into the future. Whether you're looking to lower electricity bills, increase your home's energy independence, or just geek out on renewable technology, solar energy has never been more accessible or efficient. If you want to take it deeper into how to size a solar array for our own home or which panel technology to choose, make sure to check out the links in the description below. If you learned something new today, hit that like button, Share this video with a friend and let me know in the comments. What's your favorite renewable energy source?